is if you had a choice, I'm going to try to make them show up on the screen there, between this measuring device and this measuring device. It doesn't work, my battery is dead, okay? But this is, you know what this is called? It's called a caliper. Some of you will be using it in different industries. When you, for example, let's say you're making something round and you want to make sure you get that the diameter of that round object that you're making, you can measure it with this thing called caliper. If you're making a can, let's say, zoom out even more, then you can actually use like this back side of it to, let's see if it's gonna let me, yeah. You can actually measure from end to end and then read a digital screen that tells you exactly what that diameter is on the inside, okay? Have you ever heard of ID and OD? Inside diameter, outside diameter. The reason I'm telling you this is because when I worked in an industry, they just thought I would know. Yeah, the ID is this, the OD is this. I'm like, come again, right? Like, so if that ever happens to you, you know. So if you had to pick between these two, which one would you say is more precise? Between these two measuring devices, would you take the ruler? Would you take the caliper? Do you know what you would take the ruler? You good ruler? You'd say it's more precise than this thing? Unfortunately, my battery died, so I can't show you what the numbers are here, but I'm not going to use a Sharpie on it because that'll ruin it. But if I told you that this thing measures, it would show you a measurement like this, 2.138. And then you measure with the ruler, right? You use the inches part, and the best you can get is 2.25, right? If I measured something with this ruler, I could probably get as close as 2.25 inches. If I measure with this thing, it's gonna give me a lot more decimals, right? So the answer is, I hate to say this, but this is more precise. This thing would get you a lot more precision. You would get right down to 3 decimals. So if you were manufacturing something, you would probably want to use this as opposed to this. If you're just making something like out of wood and you're just doing something in the shop, like this will do just fine. But if you're making something that's supposed to fit somewhere precisely, you probably want to be using this thing, right? The caliper. So and it all comes down to which one gives you like a higher degree of precision, which one is using more decimals, right? The more decimals that thing shows you, the more precise, right down, the more the potential of being right on to where you're supposed to be, okay? So let's go to page 80 here. And I'm just going to tell you, when you're dealing with precision, I'm just going to turn off that light there. Page 80. If you will potentially be asked to find the precision and uncertainty multiple times on a test and throughout this unit. And there are 3 ways that I can present it to you. Okay. Stating, so I'll call this page stating precision and uncertainty. Think of uncertainty as you're not quite sure. There's a little bit of a margin of error. There's a way you can be off because you're limited by your measuring device. Okay. So if it's a number, we'll do some examples there. So, and then it's going to be a picture or image, or it's going to be in words. Okay. And I'm going to show you how we do that in each case. And here it is. So let's say you're given a number and something reads 100 or 17,851.25 kilometers. Let's say you're given a measurement. It's like, hey, state the precision and the uncertainty. So you're supposed to say, based on that number, that measuring device you used to measure that, what was the precision of that thing and what was the uncertainty. So the precision, you actually go down to that last digit here. You focus in on this and you notice that it is 2 decimals away, right? After the decimal point, there's 2 values there. So you go 0.01 of a kilometer. That's how precise that measurement device was. You focus on that last number, so you're saying this one is close to the nearest 0.01 of a kilometer. That's how close you can get to that measurement. Because the next, if you go up, it would be 26. If you go down, it would be 24, right? Like it would just go up by 0.01 of a kilometer. Uncertainty. Anybody remember how to get the uncertainty? Yeah. Precision. That's right. Exactly. So you just, once you have your precision, which you need to think a little bit about, the uncertainty should be a no-brainer. So you take 0.01, you divide it by 2, and U is, if you do this, it'll be 0.005. That's how it goes. You basically just insert another 0, and then it's 5 of a kilometer. So if you're given a number, you look at the number. What if you get, so this was one example. Let's do another one that involves a number that involves fractions. Oh my goodness, right? Don't want to deal with that. What if you had 7.5 of an inch? You get a measurement. It's like, hey, 7.5 inches. We don't know what device you used. We don't. So we have to go by the number. So you focus on the smallest increment that you can possibly see, and this says it's 1/2 inch increment. So if this had been a quarter or 1/8 or whatever, you would just go by that and say that is what the precision is. And your uncertainty, hey, if you don't like fractions, convert it into a decimal, because most of you are comfortable working with decimals, right? So how about we just stick with a decimal? What's half of a, if you take 0.5 inches and divide it by 2, what are you going to get? 0.25. It's a quarter. It's a quarter of an inch. So you basically double your denominator there. So that's how you do, that's how you state the precision and the uncertainty if you're given just a number. Okay. How about picture/image? So here you're going to have to draw a little bit. So let's say you had a gauge. So let's draw a gauge here. Okay. And we're gonna make 4 lines like this, markings. 1, 2, 3. That time to get up. So make those 4 marks like that. and then split them up in smaller, like smaller lines in between. Okay. So 4 big lines, and then you split those gaps in half. Okay. So I'm going to say this gauge is going to tell us what the temperature is in degrees Celsius. Right, so put degrees Celsius there. And we're going to go that this is 80 degrees. This would be 100. This would be 120. And this would be 140. Sorry, I'm going to zoom in a little bit so you can see that. Okay. So 80, 100, 120, 140. I took a lot of pictures yesterday at home of various devices that measure different things, temperature, distance. So I'm making some ACs to get you to practice this. So if I told you, hey, state the precision and the uncertainty of this measuring device, you have to just look at what is it going up by. So you're kind of thinking you're going from 80 to 20, but there's something in between, right? How much would you say just by looking? Most of the time you can just look. Well, how much is it going up by from one to the other? 10, right? Would you say 10? Because look, 80, 90, 100, 110, 120, it works, right? So it's 10 degrees Celsius is your precision here. This thing can only tell you 10 degrees at a time, increments. So the uncertainty is just half of that, 5 degrees Celsius. So for precision, I'll put a little star here, 2 stars like that. Just look at increments. Or you can't see that because I'm zoomed in, right? No problem. So start next to this, because once you get your precision, uncertainty is easy. So let's say you get the precision wrong. For some reason you put 20 in. If you get your uncertainty, you divide it by half, you still get 1 out of 2 because you're telling me that you know how to get the uncertainty. So I would say don't ever leave anything blank. Okay. Words. Okay. How about this? A measuring cup has markings of 150 milliliters. Or page 80. If it says something like this, blah, 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 has measurings of this, you should be like, okay, I got this. Mr. Dirksen told me, like the markings, right? It has markings that go up by 150. That's really what it is telling you. So now imagine this, right? Let's say we have this measuring cup like this, and we imagine that it will have markings like this. And so let's say it starts with 150, it would be 300, 450, and this is all in mLs, right? So that's what you're imagining when I tell you that. This is what they're saying. So it's almost like a picture, but it's easier because they're telling you straight up, right? So my precision is 150 mLs. Uncertainty is 150 divided by 2. I know it's Monday morning. That's not Monday morning. Feels like Monday morning, but what's 150 divided by 2? Mental math. 75. So now you're like, yeah, now I got this. It's always going to be as clear as can be. Not always, but I was hoping that this was going to help you actually, be able to kind of compartmentalize or kind of know, okay, this is what I can expect. Any one of these, and Mr. Dirksen is going to ask me for the precision and the uncertainty given that. So it's just a plain number, then we focus on the decimals or smallest fraction, right? If it's a picture, I'm going to look for how much is it going up by? How much is it going up by, right? And if it's words, then just look for the markings, right? I will tell you this though, because these ones get a little trickier. There might be more markings along the way. This is how I would do it. I look at the two numbers that are given that are next to each other. So I would go 100 minus 80. So to take this one minus that one, and then I divide by the number of gaps. How many gaps are there between these two numbers? In this case, it's 2. So you go divided by 2. So that'd be 20 divided by 2, which is 10. Right? That's how I got that precision. So sometimes it's as easy as just looking at it, but sometimes you might have to say, let's subtract these two numbers and divide it by the number of gaps, because then I know how much I'm going up by. Okay? So there's that. Anything else? Oh yeah, I will make a little note at the bottom here, because I was looking at the questions that I'm going to assign. Right, so here at the bottom, the measuring device, write this down, this is important, I'm going to highlight that. The measuring device with the smallest increments is more precise. Ooh, I just butchered that precise there, sorry. Is more precise. That's a big one. That's a big one to know, because I will ask you, hey, if you had to pick between these two, which I just did this morning, it was probably not the greatest example because the screen wasn't working on my caliper. But if you had to pick, it'd be the one with the smallest increments. So let's say I tell you, hey, would you take this one or this one? If it's like both the same units, which one of these would you pick? You would have to pick this one. You'd have to say this one goes up by less, right? Because it goes up by 0.01 versus 0.1. So this one is the winner. If you have a device that goes up by centimeters, or the other one goes up by meters, which one would you pick if it's just looking at the units? Which one is more precise? Centimeters. Because centimeters is a smaller, right? Imagine going up by a meter at a time versus a centimeter at a time. Centimeter is more precise. Okay? So that is that. So we talked about precision uncertainty quite a bit. That's where a lot of math comes in. What is accuracy? Do you remember what accuracy is? Other than Ben, you've been doing your fair share here. Accuracy, you can cheat a little bit if you want to go back, but if you had to just use your own words. Joey. How often it is correct? I think what you're trying to say can be repeated, right? Accuracy, you should be able to repeat it. So if Joey says this football field measures, what's a football field like again? How long is it? Yards, yeah. 100, and is it over 100?
I don't know. I think I'm an artist.
Okay, right on. Dino, what were you gonna say? How close it is? Keep going, keep going. You're getting there. To the true value. How close you are to the true value. There you go. You were close. You were very close, right? You're very accurate, almost accurate. So there you go. How close you are to the actual value. So let's just quickly make you look at that. There are two things that need to happen for you to be accurate. You have to have a standard unit, so centimeters, meters, inches, cups, teaspoons, tablespoons, anything standard, and the scale has to be appropriate. So if you're in a big factory and you're making bread and you have tons of flour, tons, like thousands of kilograms of flour just waiting, would it be appropriate to use a tablespoon to get your flour for the bread? Be a horrible scale, right? Like it just wouldn't make sense because you're making big batches at a time. So you'd probably use like buckets or like something big, right? So the scale has to be appropriate. Distance between cities, don't use inches, right? You'd use miles, kilometers. Distance between Sizzler and your house, probably kilometers as well. Maybe yards. 2.5 kilometers. Okay. There you go. Some of you could probably do yards, hundreds of yards maybe, right? So, but definitely not centimeters or inches, right? Would probably not be a good idea. And also remember that accuracy can be affected by improper or careless use of the measuring device or a damaged measuring device. So if you leave a plastic ruler out in the sun on a summer day where it gets to plus 40, it's probably gonna warp or do something, right? So you probably wouldn't want to use that to measure anything. We don't talk about that. Math, we don't do real life here, except for when it works. No, it's true. Like, but you would want to focus on the actual device. Yeah. Did you know that fuel pumps, right? They adjust the volume because like, when it gets really cold, the volume of fuel actually changes, right? So the measuring tool has to make up for it. So they actually correct. Have you ever seen correct it to 20 degrees Celsius or something like that? It says it on the pump. There's a sticker. So we'll pause here. Do that right. But, all right, let's go very quick. Explain whether if the following measurement would be accurate, right? State why or why not. So basically, just do what I've been showing you in your notes, right? You're using the length of your foot, so not a standard unit. Okay. Scale is appropriate though. Therefore, this is in math, 3 dots like that is therefore. Don't ask me how they came up with that. Therefore, not accurate. You need to have a check mark. So basically what this is saying is the unit fails, the scale is appropriate, but as soon as one of them fails, it's not accurate. Okay? Using a teaspoon to measure the amount of baking powder. Teaspoon is actually a standard unit. So we'll say unit is standard. So I'll do it a little differently, but I'm saying the same. Standard. There. And the scale is appropriate. Check. So therefore, it's accurate. Talk about those two things and you're golden. So study sheet, I'd say accuracy, scale, and unit, right? Just make yourself a little note, scale and unit, right? Circle the measurement that's more precise. So between these two, they're both in meters. Look at the unit first. And because this one has 2 decimals, this one wins. I look at the units. Okay, they're the same. This one has more decimals, so this one is more precise. This instrument, don't look at the number of decimal places, not the number itself. Okay. And then between these two, you look at the units, meters, millimeters. Millimeters win. Smaller. You're always looking for the smaller increment. Joey, you get to keep this. That's why I just started correcting this. And then between these two, I was hoping you could see it, but this one goes up by 100, right? Do you see that? 100 milliliters. This one goes up by 50 milliliters. So this one is actually more precise. I hope you're starting to understand what this unit is all about. And then here, state your precision and uncertainty. This one is, the precision is 0.01 of a centimeter. And the uncertainty is half of that, which is just that. So if it's one of those 0.01, if you divide it in half, add a 0, like squeeze a 0 in there, and it's 5, right? And if not, just use your calculator. Here, it's precise to 0.1 of a kilogram. Always have units. Always have units for both. Look at what I'm using. Is it Celsius? Is it Fahrenheit? Grams? Hertz? You'll see hertz, like sound, right? So make sure you're aware of that. Here, I'm looking at increments. So it's 50, right? 50 mLs. And so the uncertainty is 25 mLs. Right? So that's how this is done. Okay. So this is basically just making sure you understand accuracy, precision, uncertainty. And now we're going to take it a little further, okay? Nothing, like it's still precision and uncertainty, but how it works when you combine things, okay? So keep this. It's a gift to you. Early Christmas present. So go to 85 in your booklets. Okay, so in this example, you're mixing juice in a jug marked in quarter liters. Dun, 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 right? You should have right away picked up on that. I will not highlight that on a test, but you should mark. What is that telling me? It's telling me that the precision, quarter liters. How are you going to write that? Well, 0.25 of a liter. Right? So this device has markings that go up in quarter liter increments. She measures the amount of the juice in the box to be 2.5 liters. So that's the actual measured value, right? Actual amount of juice in that container. Write the measurement of the juice in the jug in this form. So they want you to, we're going to start writing it like this. So the measured value is the 2.5 liters. So you go 2.5 liters, and then you go plus or minus the uncertainty. We need to figure out our uncertainty, right? Common mistake is students just put down the 0.25, but that's not right. Uncertainty is 0.25 divided by 2, which is 0.125 of a liter. And this is my uncertainty, right? So we're going to go plus or minus 0.125 of a liter. These units could be different. In this case, they're the same, but we just write it like that. So that's what they wanted you to write. Take the actual amount you have, right, plus or minus the uncertainty, which we got from this word. In words, they told us what the precision is, and we got our uncertainty from that. You need your precision to get your uncertainty. Let's just put it that way. Okay, next, this is probably a little bit, I can't remember talking about this, but what's the smallest and largest possible volume that could be in the jug? So smallest, we will call this our minimum, right? You take 2.5 liters and you subtract the uncertainty from it. So you're saying, what's the lowest possible amount you could have in that jug? And that is, did I work this out right? 2.125. Is that right? Doesn't seem right. More like 375. So to make sure I don't make a mistake, yeah, there we go. It is 375 liters. Right? So you're using this to get that lowest value, and then the largest amount possible that you could have in that jug, that's called our max, is 2.5, the amount you're reading plus the uncertainty. So you add them up, and that's 2.625 liters. So this is the greatest amount, the smallest amount you could have in that jug. And the reasoning behind it is because we all kind of just ballpark measure something. Like sometimes it's not visible to the naked eye, but we all kind of say like this is about that. Like it's not always exact. So this is kind of making up for that. You could have as little as this or as much as this. Okay. What is the range of the volume in liters that could be in the jug? So I'll write this formula down here. Range would simply be taking the max and subtracting the min. Like you take these two values and you subtract them. Max is 2.625, min is 2.375. And that's 0.25. Yeah. That is 0.25 liters. I would box this in to just have that, like what the range is. Just take those values. So the min and the max is easy to get. You just have to go minus to get the lowest, plus to get the highest, right, from the measured value. I would like you to try this right now. Just question 12, just the one that's underneath it. Please try that right now. Question 12. That's basically along the same lines that we just done. If you have a highlighter, I love highlighters now. You know that, right? So Frank measured his height at 1.75 meters using a tape measure marked in centimeters. And that should ring a bell. You should be like, wait a minute. Because of that, that trumps anything else that shows up. This is where you get your precision from, right? So we from there, I'm just going to right away say, hey, precision is 1 centimeter, and uncertainty is half of that, which is 0.5 centimeters. Okay, don't get it from this. You get it from the markings. If this had been absent, if the markings had not been there, you would have gotten your precision and your uncertainty from here. What would your precision have been if you just looked at this number? It's just a pop quiz. Precision is 0.01 of a meter. Got it? But it's not. It's giving us markings, so we go by that. Okay, so what's the measured value plus or minus uncertainty? We take the measured value, we go 1.75 meters plus or minus the uncertainty, which is 0.5 centimeters. Notice that the units are different. It's okay to state it like this, but because I know what's coming down the road, I will convert this to 175 centimeters. Right? I just multiply that by 100 to get it to centimeters, and then it's plus or minus 0.5 centimeters. Both units are the same now. Okay, this is acceptable though. That is acceptable. Okay, and then it's asking, what is the range of the possible values of the height? So what's like the range is like the difference between the min and the max. I first have to figure out the min, which is 175 minus 0.5. That's 174.5. Okay, and the max is 175 plus 0.5, which is 175.5 centimeters. And so then I can find the range. The range, if you recall, is max minus min, which I've just figured out. So you take your max, subtract your min, and then you state that the range is 1. We're in centimeters, so it's 1 centimeter. There's a 1 centimeter difference between the highest and the lowest possible height. So not bad, right? It's only a centimeter difference. So once you've copied this, I want you to go to the back side, and that's what we're working on. Some of you are going to be done right away. That's okay. I'll give you the rest of the class to just read a book or do whatever. You need a bit of a break because I know it's tough in the morning sometimes. So instead of starting the new concept, I'm just going to pause here, let you take some time to maybe review your notes, beef up your study sheet, whatever you need to do. I would have accuracy, precision, uncertainty, how to get the range, right? Max minus min, right? Stuff like that maybe on there. And write lightly so you can erase and then maybe start again. Don't use a pen or anything like that just yet. So I'm going to get you to do page 86. And hold on, I have down the road there's one more. Page 90, question 4 and 5. Yeah, page 94 and 5. 4 and 5 only. Don't do anything else on page 90, okay? So I'd say if you don't finish this, you do it as homework, okay? Go ahead and do this now, okay?